Hi folks, and welcome back to another Philosophy Club. Okay, so this week we're going to look at science and pseudoscience. But first we're going to need to define what science is and science is not. So, science comes from the Greek word scientia, meaning knowledge. The scientific method then is on the constant search for knowledge and truth, and while doing so, looking for ways to always improve its method. And in doing so, it needs to separate what science is from non-sciences and also pseudosciences. Now, pseudosciences might sound like a funny word, so we're going to explain what it means. So, pseudoscience comes from the Greek word pseudo, which means false, and then science, as we said, means scientia, which comes from the Greek word for knowledge. So, pseudoscience then means false knowledge. So, why is separating science from non-science so important? Well, today lots of things claim to be scientific that aren't. They might mislead you, they might pretend to sound scientific and come across as scientifically rigorous when they aren't. And in some cases they can waste your time and money, and in others they can be harmful or even dangerous. So it's good to know the difference between science and non-science and pseudoscience. So, one man made it his mission to separate science from pseudoscience, and his name was Karl Popper. And to do so, he argued that we needed to change the way we did science, or at least put an emphasis on a different aspect of the scientific method. Scientists, up until that point, emphasized verification and confirmation of their theories. Popper wanted to emphasize something else. He argued that the most important thing in separating science from pseudoscience was the idea of falsification. Now, what's falsification, I hear you ask? Falsification is just a fancy way of saying part of what makes a good scientific theory is the capacity for it to be proven false. So, take for the following example. If I said all swans are white, and then to prove it I went around pointing out all the white swans I could find, you'd probably tend to agree with me. But Popper thinks that a better scientific method would be to try and prove all swans are white to be false. Well, how would you prove that to be false? All you'd have to do is find a swan that isn't white. It's pretty simple. So, the theory can be proven wrong or falsified by finding a non-white swan. I could go on forever pointing out each white swan that I found, but there's always the possibility somewhere that a non-white swan exists, so I can never be certain. Of course, confirmation and verification are important to prove my theory, but I only need one example of a white swan to prove it false, and for Popper that's the beauty of falsification. It's much more simple. So if we try to prove theories false, then it is easier to separate out good theories from bad ones. The better the theory, the more attempts to prove it false it has survived. So for any good scientific theory, we would know how it could be proven false theoretically. We can clearly see how to test its truthfulness. And testing is the basic part of falsification and also of good science. If you can test something, then you can say whether it is true or not. So, that's a quick glance at falsification, but could you spot a pseudoscientific theory? To help you with that, here's a quick list of features to look out for when suspicious of scientific claims. There are plenty more features of pseudoscience, but here are some of the more common ones. So, as we said, they're not falsifiable. They make vague claims that aren't precise or measurable. If a claim is vague, it means it's hard to tell whether it's truthful, and if you can't measure it, you can't test it. They use jargon, or special words that are difficult to understand, that often sound scientific, but are really just made up or meaningless. They cherry-pick data that suits their claims, and ignore data that disproves them. Good science will often go with the explanation that has the fewest assumptions. Pseudoscience, on the other hand, will often have many assumptions that could be better explained by simple scientific theories and explanations. So, say for example, UFOs are ghosts. A lot of those theories and explanations assume a lot of very unrealistic things that could be explained by quite simple science or natural phenomenon. And finally, their claims are not accepted by other scientists or scientific bodies. So, knowing these features might help you sort out science from false knowledge, or pseudoscience. Of course, just because something isn't science doesn't mean that it isn't also useful sometimes, but we need to be sure that the scientific information that we do come across is good and isn't misleading. Okay, that's it for this week. I'll talk to you soon. In the meantime, take care.